So today we are going to be doing a implicit differentiation. You are going to be deriving using a implicit method. So this is what you are going to do on your given equation. So we are given that x squared plus sine y is equal to 1 plus xy. So what we are going to do here, you are going to multiply both sides. You are going to multiply both sides by what? By checking on what you are trying to derive. They say find dy over dx. And if you can check, your denominator has dx here. Has dx. Meaning you are going to multiply both sides by d over dx. And then you multiply this side by d over dx. Then after doing that, you are going to do what? To distribute. Distributing, you're going to put this dx. Now, how can I derive 2x? To derive 2x, I will get what? To derive x squared, I will get 2x. So what did I derive? I derived what? X with respect to what? To dx. That's what happened. So let me go to the sign. What is the derivative of sine? The derivative of sine, something, is cos something multiplied by the derivative of something. The derivative of y is 1. Then what did we derive? We derived y with respect to x. Then we say equal sign. So we go to the right hand side. The derivative of 1 is what? Is 0. That is a constant, plus. Now we have two things that are multiplying each other. We are going to use what? Product rule to derive them. So what is the derivative of x? The derivative of x is 1. What did we derive? We derived x with respect to x. Then we keep the second function, which is y. Then we say plus. We keep x, then we derive y, we get 1. What did we derive? We derived y with respect to x. So that's what we call implicit differentiation. From there, you can see this one cancels this one, and this one cancels that one. So most of the time, deriving x, there's no need for you to write dx over dx because they will simply cancel each other. Here, I'm just showing you how those things disappear. So here, I'm going to be left with 2x plus the cos of y. Then I have dy over dx, which is equal to, then that side I have what? I have y plus x dy over dx. Remember, what is my aim? My aim is to find the dy over dx, and I have two of them. So what can I do there? I can do what? I can group them. I can take the dy over dx on the left hand side, and I take everything on the right hand side. So meaning from here, I will get what? I will get cos of y dy over dx. Then I take this one on the left hand side, I will have negative x dy over dx. Then everything on the right hand side, which is y minus 2x. Then from there, I can see I have what? I have common factor of dy over dx. That is why I moved them on the left hand side. So I remove the common factor of dy over dx. So inside of that expression, I will remain with the cos of y, the cos of y minus x, close bracket, equal sign. Then I have y minus 2x. Remember, my aim is to find what? Dy over what? Over dx. This is my aim. My aim is to find this. So which means I'm going to divide both sides by whatever that is here. I divide both sides so that I can remain with this one only. So by dividing both sides there, I will get that what? My what? My dy over dx is equal to y minus 2x, all divided by what? By the cos of y minus x. So that's how we find the dy over dx of whatever that is here, using what? Using implicit differentiation. So let's move to number 2. Number 2, we are given that. So they are saying to us we must do what? We must find dy over dx using whatever that is given there. So from there, what I can do according to me, I can cross multiply there to save myself a time to use a quotient rule. So I will have what? I will have a x plus the sine of y. If I cross multiply by y, which is equal to what? Which is equal to x. So which means from there, I have what? I have that x is equal to y into x plus the sine of y. So what is the first step? The first step is to multiply both sides by what? By whatever that I'm willing to find, which is d something over dx, which means I'm going to multiply both sides by d over dx. I multiply this side by d over dx. Then from there I start applying. What is the derivative of x with respect to x is what? Is 1. Ne? Then equal sign. There's no need for me to write dx over dx because simply is going to cancel each other. So here, if you can check, I have the product of two functions here. I can call this one f, this one g. So to derive them, I'm going to use what? I'm going to use product rule, which means I derive the first one, which is what? Which is y. Then I get 1. What did I derive? I derived y with respect to what? With respect to x. Then I keep the second function, which is g. Understand? Then I say what? I say plus. I keep what? I keep the first function, which is y. Then I do what? I derive the second function, which is g. So to derive g, I will derive x. When I derive x, I get what? I get 1. Then I derive what again? I derive sine. When I derive sine, the derivative of sine something is cos something multiplied by the derivative of that something. So which means a derivative of sine is what? Is the cos of y multiplied by the derivative of y, which is 1. What did I derive? I derived y with respect to what? With respect to x. Then I close my brackets. Then from there, I simplify. I have 1, which is equal to what? Dy over dx. Then I have x plus the sine of y. Then here I have what? Plus. I still have my expression, which is y into 1 plus the cos of what? The cos of y. Then I have what? Dy over dx. So sorry, close bracket. If you can check there, this is my dy over dx that I'm willing to find, and this is my dy over dx. But the problem with this one is inside of the bracket, which means I have to distribute this bracket so that I can find it easily. Which means from there, I will have that 1 is equal to what? Is equal to x plus sine y multiplied by dy over dx plus. When I distribute the variable y, I get that y plus what? Y, the cos of y multiplied by dy all over dx. So if you can check, there's what I'm looking for here. So I can take these ones on the left hand side, then I put these ones, I put these ones on the right hand side. So from there, I take the one that has dy over dx on the left hand side, which is going to be x sine y, then dy over dx plus y cos y dy over dx. Remember these ones that I'm writing them here, it's like they remained this side. That is why I did not change their signs. Ne? So which means this one, they are the one that this one is the one that is jumping the sign. So I'm going to remain with what? With 1 minus y. So from there, I'm going to remove common factor of what? Of dy over dx. I will have that my dy over dx. Then in my inside expression, I remain with x plus the sine of y, then plus what? Plus y, the cos of y, which is equal to 1 minus y. From there, I will do what? I will divide both sides by this thing, since what is a multiplication. So let me divide both sides by that. When I divide both sides by that, I get that my dy over dx is equal to 1 minus y, all divided by what? All divided by what? By x plus sine y plus y cos y. Then from there, you find your dy over dx using implicit differentiation. Let's go to number 3. On number 3, we're going to do the very same thing. We do what? We rewrite our expression. We have ln y, and then we have y into x minus 1. Then what is the first step? The first step, we multiply both sides by d over dx. I multiply this side by d over dx. So from there, I see my variable here is what? Is y. And then what is the derivative of ln something? You must know that the derivative of ln something with respect to something like this, the derivative of that is equal to what? U prime over u. We derive that something, then we keep that something in the denominator. So from here, which means I'm going to derive y. When I derive y in the numerator, I get 1. Then what did I derive? Remember, I am deriving y with respect to x. Then I do what? I divide by the inside function, which is y. So this is equal to. Then this side, if you can see, I have the composite, I have the two product, which is this one, I can call it f. Then this one, I can call it my g. Which means to derive that thing, I have to use my what? My product rule. I will derive f first. When I derive y, that f, which is 1. What did I derive? I derived y with respect to what? To x. Then I keep g. Then I say plus. I keep y. Then I derive what? G. When I derive g, I will get what? 0 minus what? Derivative of x is 1. And then derivative of -1 is 0. Then which means what did I derive? I derived x. So there's no need for me to write dx over dx. From there, what is our main point? Our main point is to do what? Is to find this dy over dx. So from there, which means I can do what? I can put them on what? On the left hand side, both of them. So from here, before I put them on the left hand side, both of them, I can multiply both sides by y. Meaning I can find what? I can multiply both sides by y like this. I multiply both sides by y. Then I multiply here by 1, so that this one can cancel that one. So I will leave with what? I will be left with a dy over dx, which is equal to what? I can distribute that y, which is equal to what? Y into x minus 1. Then I have what? I have the dy over the dx plus, when I multiply that y, I will get what? Y squared, because this thing is simply equal to 1, this region here. So from there, I will group the dy over dx. When I group them, I will find that dy over dx minus y into x minus 1 dy over dx is equal to y squared. So which means from there, I will remove common factor of what? I will remove common factor of dy over dx. So let's remove that as a common factor. We have our dy over dx. We are remaining with the inside part, which is going to be 1 minus y into x minus 1. I close the bracket, which is equal to y squared. From there, I'm going to divide both sides by this thing so that I can remain with my dy over dx. So from there, I'm saying therefore my dy over dx is equal to y squared all divided by 1 minus y into x minus what? Minus 1. So I found my dy over dx using implicit differentiation. So let's go to number 4. On number 4, we have the very same thing, not same thing, sorry. We have our sine of y, our sine, this is the same as sine 1 over 2y, which is equal to what? That thing, when I simplify it, is the same as 1 minus 2x squared all to the 1 over 2. So now I can multiply both sides by what? By d over dx. I multiply here by d over dx. I multiply here by d over dx. So what is the derivative of sine something? The derivative of sine something is equal to the cos something multiplied by the derivative of that something. So which means our answer here is going to be the cos of that something multiplied by the derivative of that something. What is the derivative of 1 over 2y? Is going to be what? Is going to be 1 over 2. What did we derive? We derived y with respect to x, which is basically equal to. On the right hand side, to derive this guy here, we must use what we call what? A chain rule. So which means we drop what? We drop the exponent, we keep the inside function, then we subtract 1 from our exponent, then after we multiply by the derivative of whatever is inside. The derivative of whatever is inside is going to be negative 4x. Then I close my bracket. So which means I did what? I derived x with respect to x so that these things they cancel. From there I simplify, which means I'm going to be left with what? With the cos of 1 over 2y, then is multiplied by that 1 over 2 multiplied by dy over dx, which is equal to, if you can watch there, 1 over 2, this one, 1 over 2 minus 1, this thing is equal to what? This thing is equal to negative 1 over 2. So which means here I can just rub and write what? And write a negative 1 over 2. Negative 1 over 2. So that negative exponent, it tells you that thing, this negative exponent, it tells you that this expression, this whole expression, this one, is going in the denominator, and when it gets in the denominator, it's going to be a positive here. Understand? So which means from here, I have 1 all divided by what? All divided by 1. Oh, sorry, I still have that 2 there. This 2, this one. So I have 1 minus 2x squared all raised to the positive 1 over 2. So I still multiply by what? I multiply by this guy here, which is negative 4x. I can put it in the numerator, which is negative 4x. Then from here, you can basically see that what? This 2 will cancel this one to remain with what? With 2. Then from there, I can clearly see that what? I have 1 over 2, the cos, or I can just say I have what? I have cos 1 over 2 y divided by 2. Then I have my dy over dx, which is equal to how much? Is equal to negative 2x divided by what? Divided by the square root of 1 minus 2x squared. Then from there, I want to find dy over dx alone, I can multiply both sides by the reciprocal of whatever that is here, which means I will multiply both sides by what? Let me put this thing closer to dy over dx so that I can multiply. Sorry, made a mistake there. Then from there, which means I can multiply both sides by what? By 2 over the cos of 1 over 2y with, let me just multiply there. I don't know why I'm doing this. Then which means from here I will multiply both sides by 2 all over the cos of 1 over 2y. Even this side I multiply by what? By 2 all over the cos of 1 over 2y. So that this one can cancel that one and this one cancel this one. Which means, therefore, my dy over dx is equal to what? 2 times 2 is what? Is negative 4x all divided by what? Is going to be what? The square root of 1 minus 2x squared multiplied by the cos of 1 over what? 1 over 2y. So that you got your dy over dx using implicit differentiation. So let's go to our number 5. On our number 5, I can see, before I can start solving, I see 2 limbs, and then I'm thinking of 2 things. The first limb, it is what? It is ln, I can say ln u raised to any exponent. We can call that exponent n. So basically what is going to happen with limb, that n will drop it and we keep ln, we keep that u. That is what is going to happen. So checking here, I have what? I have ln something raised to exponent, which means I'm doing what? I'm going to drop that exponent. I keep the what? I keep the e. And then I know that what? ln e, this one, is equal to 1. So basically here I have what? I have x multiplied by 1, which means it's the same as I have what? I have x minus lim y, which is equal to e to the y. From there I can do what? I can just multiply both sides by what? By d over dx. By d over dx. I multiply here by d over dx. Then I start to do the things. Which means from here, I will do what? I will derive my left-hand side. The first one is x. The derivative of x with respect to x is just 1. And then minus. The derivative of that is going to be derivative of y, which is 1. What did I derive? I derived y with respect to x. All divided by what? By y, which is equal to. On the left-hand side, I know that what? The derivative of e to the u is just e to the u by itself multiplied by u prime. So it's going to be what? It's going to be e to the y multiplied by the derivative of y, which is 1. Then I do what? What did I derive to get 1? I derived y with respect to x. So now I can clearly see I have what? I have my dy over dx on the left, and I have my dy over dx on the right hand side. I can group them, both of them, to be on what? On the right hand side or the left hand side. So the simpler way is to put them on the right hand side so that sign cannot affect many things. So when we are putting it on the right hand side, it's going to be like in the left hand side. This is what I mean. I'm going to have e to the y, then I have dy over dx, then I have plus what? But before that I can see something, but it's fine. Plus what? Plus 1 over y dy over dx, which is equal to 1. From there I remove common factor of dy over dx. I will remain with dy over dx, all into what? Into e to the y plus what? plus 1 over y, which is equal to 1. Then from there, I can do the LCD here. I can do the LCD. Doing the LCD there, I will get what? I will get e to the y multiplied by y plus 1 divided by y. Understand? Which means from there, my answer will be something like dy over dx. Then I have what? I have my e to the y multiplied by y plus 1 divided by y. So from there, this is all equal to 1. So from here, I will multiply both sides by the reciprocal of this, which means this side, I'm going to have the reciprocal of what? Of that, which is what? Which is y all over e to the y multiplied by y plus 1. So which means from there, my what? My dy over dx is equal to what? Is equal to y all over what? All over y e to the y plus what? Plus 1. Then from there, you are done. You find your dy over dx with respect to y. So I go to number 6. Number 6, they are saying we must derive that using implicit differentiation. We know that the derivative of cos something is negative sin something multiply the derivative of that, which means from here, I will multiply both sides by what? By my d over dx. And then on the right hand side, I will also do the same. I will also do the same to get what? To get my dy over dx. So I d over dx, d over dx. Then I start to do the things. Derivative of course is something is going to be negative, sine, whatever that is inside, multiplied by the derivative of the inside thing, which is 3. What did I derive? I derived y with respect to what? With respect to x. Then on the left hand side, I know the derivative of tan something is equal to what? Secant squared something multiply by derivative of something inside part, which is 2. So from here, I can clearly just divide both sides by this expression. So which means my dy over dx will be equal to what? Will be equal to 2 sec squared 2x divided by what? Divided by 3 sine 3y. Then that negative will come here in the numerator. Then from there you are done. Let's go to our number 7. On number 7, we are going to do the very same thing. We are going to multiply both sides by d over dx, which means you have equal sign x squared y plus x y cube, which is equal to 2. Then I multiply both sides by d over dx, d over dx. So the first part, I have to derive x squared and y using product rule. So which means when I derive x, I will get what? 2x. Then I derived x with respect to x, can write like this. Then I keep the y, I say plus, I'm still deriving this part. And then I keep x squared, I derive y, which is 1. Then I got what? Dy over dx. Then plus, now I'm deriving this part. I derive x, I get 1. I keep the y cube plus, I keep the x, I derive y, I get 3y squared. I derived what? I derived y with respect to x, which is equal to derivative of 2 is what? Is 0. So from there, I group my things. I group these things. The dy over dx. I keep them on my left-hand side. So which means from here, I'm going to be left with x squared dy over dx plus what? Plus 3y squared x dy over dx, which is equal to, everything is going on the left, which is the same as minus 2xy. I'm moving this one on the left hand side, and I'm also moving this one on the left hand side, which is what? Minus y cubed. So I remove common factor of dy over dx there. I get what? I get x squared plus 3y squared x, which is equal to what? I can remove common factor of negative if I want. I have 2xy plus y. Then from there I can divide both sides by this guy here. So when I divide both sides by that, I will get that what? My dy over dx is equal to negative 2xy plus y, all divided by what? X squared plus 3y squared x. Still fine? Then let's go to number 8. On number 8, we're going to do the very same thing. Multiply both sides by d over dx of what? Of the cos of y plus the cot of x, which is equal to what? D over dx all raised to what? E to the x y. So from there we do the things. What is the derivative of cos? Derivative of cos is going to be what? Sine y multiply derivative of y, which is 1. I derived y with respect to x, plus derivative of cot is going to be equal to what? Negative cosec squared x multiplied by derivative of x, which is what? Which is 1. All equal to derivative of e to the something is what? Is e to the something by itself, all multiplied by derivative of that. Derivative of that, I'm going to use product rule. I derive x first, I get 1. I keep y plus. I keep x, I derive y, I get 1. Then I have the dy over dx. I close the brackets. Which means from there, my aim now is to find what? Is to keep this one on the left hand side. I have to distribute the bracket first. So on the left hand side, I'm going to have what? I'm going to have the sine of y. Then I have the dy over dx minus cosec squared x, which is equal to, when I distribute, I will get y e to the xy plus e to the xy multiplied by x, then multiply by the dy over dx. So I'm going to take this one that is a dy over dx on the left hand side, then I'm going to take that one on the right hand side. So I will remain with what? With sine y dy over dx, then what? Then minus e to the x y x dy over dx, which is equal to what? Is equal to y e to the xy plus the cosec squared x. I remove my common factor of dy over dx. I get what? I get the sine y minus x e to the x y, which is equal to what? Equal to y e to the x y plus the cosec squared x. From here I can divide both sides by this guy, which means I will get what? I will therefore get my dy over dx to be equal to what? To be equal to y e to the xy plus cosec squared x, all divided by what? Divided by the sine y minus x e to the xy. So from here we got our answer. Let me quickly charge this thing before it turns off. Then from here, we have to move forward. You don't have to stop. We're going to go to, so let's move on. Yeah, forgive my time wasting. So from there, we're going to do the very same thing. We're going to multiply both sides by what? By d over dx, which means I will have this, which is equal to that. So I have the y e to the cos of x. Then I have the x sine of y. So I will have to multiply both sides by whatever that